Okay, so welcome to the Unit 8, Lesson 4 on geometric series. All right, our objectives today is to identify a geometric series, identify it as infinite or finite, and find the sum of the series using formulas with or without the calculator. So, the first thing we have here is a couple different formulas, a couple different ways of thinking about this. So just like with the arithmetic series, we had sigma notation. So here's our sigma notation, right? This is sigma notation, all right? And then over here, this is our formula. Now the formula is what is on the formula sheet that you'll be given for the SOL, which you'll be given for the test. So if you feel more comfortable using that, since it's going to be on the formula sheet that you're given, then feel free to use it. Personally, I like the sigma notation. It's kind of straightforward typing it into the calculator with one little thing that you have to keep in mind. And that is when you enter this into the calculator, you have to make sure that there's a big set of parentheses. Your calculator will start it off with parentheses. Everything stays inside of that parentheses. You never put anything outside of it. And I think that gives some students a little bit of trouble, but you'll see you always enter things in there. So this first set of problems we're going to use with the formula. And we're going to kind of start off with the formula because if you don't have a TI-84 Plus, if you have one of the older calculators, you can't even do sigma notation. You have to use the formula. So there's a couple little caveats to the formula that you want to make sure that you understand. And part of it is looking here at trying to figure out these key things. These are the three things you need to know to be able to type it into the formula. A1, so it says here that I'm starting at 1, right? So when I plug that in to this rule, I type in 1 minus 1. That will give me my first term that I'm going to start with, right? So it's not always A1 as in the very first thing ever in this sequence, but it's the starting point that it tells you to use. It tells you to use 1. So you plug that in, and that's, of course, 1 minus 1. That's 0. So 1/5 to the 0 is 1, times 30 is 30. All right? Our R value is the number that has the exponent, so that's 1/5. And R to the n, well, that's going to be, our n is when we take the ending point minus the starting point plus 1. So that'll give me 6, right? And that little formula is important. In this case, when you're starting with 1, you have the first, the second, the third, the fourth, the fifth, the sixth. So that gives me 1/5 to the 6th. All right? But again, you want to kind of follow that formula, and we'll see how that plays out a little bit later. Okay, so let's plug it into our formula. Our formula, we'll look back up here, says the sum of 6 terms is equal to, starting at 30, and then multiplied by 1 minus 1/5 to the 6th power divided by 1 minus 1/5. Okay? So it's a little bit different than our formula. This formula, it's if you multiplied it, turn A1 into a fraction, it's top times top, bottom times bottom. So on your formula sheet, it's actually written this way. And really, we should have wrote it this way on our notes here, because if you're using the older calculator, that's a much easier thing to type into the old calculator than if you try to do it with one big set of parentheses. So they're equivalent. These two things are the same. So if I type this in the calculator, let's see how that would look, right? So I'm going to pretend like you have the old calculator where you can't do fractions. So I would type in 30 multiplied by, well, you don't have to do that. You can do 30 parentheses 1 minus parentheses 1 divided by 5. And then I'm going to raise that up to the 6th power. And then I'll close that off. Or then I will hit divided by parentheses 1 minus 1 divided by 5, close, and close. And there's the answer. The sum of these 6 terms will be equal to 37.4976. Now, if you do the sigma notation and you enter this in the calculator, just the way you see, right? Remember that's math 0. Now, it says n. You can type in n if you want, or you can just put in x. Starting with 1, going to 6, come over here, we'll do 30. Now see how it started me off with a parenthesis? Everything stays inside of that. So 1 divided by 5, close that, raise it to the 6th, and then come outside of that. So you see everything is inside of that parentheses. That's very, very important. And you hit enter. And you get something completely different. Wait, what? It's not supposed to be completely different. So what did I do wrong here? What you did wrong, or what I did wrong, was I did not keep the variable. You see, you don't plug anything into there. You should stay x minus 1. Right? If you use an x down here, use an x up there. Now if I hit enter, I get 37.4976. All right, that's also one of the most common mistakes people will make when they're putting this in. They'll fill in for the variable, but don't fill in for a variable. You actually just plug it in with x and solve it. Okay, so let's check our next problem here. And what we're going to see here is something slightly different. Notice it's 0. All right. Well, when I'm finding my A1, that means I'm going to do 0.01 times 3 to the 0 power. Well, if I simplify that, that's just 0.01. All right, there's A1. My R is 3. My R to the n. Now see, remember it's 12 minus 0 plus 1. That's 13. So I have 13 terms that I'm adding here. 13 terms that I'm adding. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. That's 13 numbers. So make sure that you do this little formula like I asked you to. All right, so how are we going to set this up? The sum of the 13 terms is equal to, starting at 0.01 multiplied by 1 minus r to the 13th divided by 1 minus, sorry, you don't want to keep the r there. If you're doing the formula, you want to do 1 minus 3 to the 13th divided by 1 minus 3. All right, so come over here. I'm going to put 0.01 parentheses 1 minus 3 raised to the 13th. Yep. And then we'll divide that by parentheses 1 minus 3. Enter. And there's our answer. The sum of the 13 terms I'm looking for is 7,971.61. Okay. So that's using the formula. If you're using the calculator, you have a TI-84 Plus with the sum notation. You're simply putting it in. The one thing I want to always remind you is that the parentheses it gives you, everything always goes inside of that. Never try to put things in front or outside of that parentheses. All right? So try to pause the video, see if you can use your calculator to find this sum. All right? Pause the video. Okay. So here's the two answers you should have gotten if you had paused the video and attempted these problems and you made sure everything was inside of the parentheses. All right? So let's move on now to the second type of geometric series, which is called an infinite series. Now, with an arithmetic series, there was no infinite sum. If it went on and on forever, you can never add it up, right? But geometric series, there is a special kind that you can actually add it up. And that's when your r squared value, the absolute value of r, is less than 1. All right, if the absolute value is less than 1, so between -1 and 1, right, if r is somewhere between -1 and 1, then you can add it up. All right, so let's talk about that a little bit. So here we have an infinite series. We know it's infinite because it just ... means goes on forever. All right, so the sum of the first term, well, that's just 1/2. The sum of the first two, 1/2 and 1/4, well, that's 3/4. Okay, now if I add an eighth to that, well, that's 6/8 plus 1/8, so that's 7/8. Okay, if I add a 16th to that, so that's 14/16 plus 1/16. So we got 15/16. Okay, and then we got 30/32 plus 1/32. We get 31/32. So what's happening here, right? As I keep adding on to another, right, as I go along this series, I'm going to keep adding on, and it's going to keep getting closer and closer to what value? 1. Right? Keeps getting closer and closer to 1. So while the series is infinite, right, the sum approaches, right? It'll never get to 1. I'll never have 1. But it approaches a finite value. And it's not always going to be 1. It's just in this case it happens to be 1. And that's okay. But every infinite series that has an r squared value between -1 and 1 will always approach a finite value. And it gets so close to that number that it really doesn't even matter anymore what you're adding to it. It's really, you can round that to an answer. All right? So there's a couple formulas for this, which we have up here. We gave you this summation notation. Notice that the last term is infinite, meaning you're never going to stop, right? How am I going to enter that into the calculator? How can you enter infinity into a calculator? You can't. But you know what? After a certain point, it doesn't matter anymore. So we can assume that 99 terms will be enough. So you can enter this into the calculator with the top number being 99. If you add up the first 99 terms, you're pretty close to what it's going to be. And so that's how we work around infinity. All right? But we also have another formula, which is the infinite geometric series formula, which will allow you to calculate this. If you don't have the brand new calculators, you can still use this formula, which will be on your formula sheet. Okay? So let's see how we're going to do this. All right? So the first one here, we will do with the formula. Okay? So with the formula, I'm looking here, we'll say the sum of the infinite series is equal to my A1, which is 2, right, divided by 1 minus my R, which is 0.1. Okay, so if I'm going to type that in the calculator, sorry, that was a 1. 1 minus 0.1. There we go. So if that's what I'm going to type in my calculator, come over here and hit 2 divided by parentheses 1 minus 0.1. Close it, and I get our A1 is 2, R is 0.1. So we plug it into there, and we get the infinite sum is equal to 2.22. You can repeat that if you like. Okay? So let's try it in summation notation. Right? Let's start here. A1 is 12. My ratio. Well, remember they find the ratio by dividing the second one by the first one. So that's 1/3. My ratio is 1/3. So I could do sigma notation of my first number is 12. My ratio is 1/3. And then raise it to the x minus 1. And that's just the formula for geometric sequences. So let's do math 0, and we'll do x equals 1. We'll do 99, and then 12, start a parenthesis, 1 divided by 3, raised to the x minus 1. Get out of there, hit enter, and syntax error. Hit division twice. Okay, let's try that again. It's going to calculate it for a while. It's going to take a while for it to calculate all 99 values and then add them all up. But you see we get 18. So the infinite sum equals 18. All right? And you could attempt that with the formula if you like. Right? The formula was the sum of the infinite series is equal to 12 divided by 1 minus 1/3. And we can type that in the calculator. Alpha y equals, for our fraction, 12 over 1 minus 1/3. And we get 18. So you see both ways works. And you just got to determine which way you like best. All right? So but remember, if it's an infinite series and the R value is greater than 1 or less than -1, there is no sum. All right? Those are called divergent sequences, divergent series, and they do not have sums. Only the convergent series, the ones that are less than 1, they converge towards a finite value. Those are the ones that will have a sum. All right, so hope you found this interesting. We'll see you in class.